Thank you. Thanks. Hi, everyone. My name is Kai Sajadi. I'm one of the guys working at Cloud 66. Just a little bit about who we are, what we do. So Cloud 66 is everything you need to have to run a Docker-based container application in production on any cloud on your own servers. So the way it works is we either build the Docker images for you from your source code, or you have your own Docker workflow. That's great, and you build it. You give us the images. We then connect to your own cloud provider of choice, DigitalOcean, obviously, and the usual suspects. We connect to those, fire up the servers for you, provision them, roll out the containers. And we also do a lot more than just taking care of containers. So there is a lot about web traffic, your visitors, the databases, replication, backups, access control, audit, firewall, security, patching of operating systems. So it's basically the whole stack of running your application in production on any cloud provider. So that's what we do. And we get a little bit like of how it works, a little bit more than that, but I'm sure you're not really interested in Cloud 66. You're more interested in like what we're going to do to help developers use Docker. So to start and make sure that I'm on the right track, I want to ask a couple of questions just for my own sake. How many of you have used Docker in development or production? Great. How many have not used it in production? OK. So we have a lot of people who have tried it in development, but not in production. Right. Great. Cool. So I think the best way for me to start is to tell you about a couple of projects that are open source free, sponsored by Cloud 66, happens to be, but we find them very useful, both for our own customers, but for ourselves. This is what we built for ourselves primarily, and we're sharing it. And I think you will find them very useful. The first one is the starter, which is what it does is essentially it's the easiest way to take your application into production or into a Docker file and make it Dockerized, right? And it's fairly simple what it does. It's an executable. It's obviously open source, and it's written in Go. You can compile it yourself if you want. You can contribute hopefully later on. But you get it on your laptop. Then you point it to your project. Let's say you have a Rails application. You point it to your project, and then it reads your source code, tries to do some basic analysis of it, and then spits out a Docker file. So that's the first step. Usually it's good because we have a lot of intricacies around how to build Docker files, and Tommy's going to talk a little bit more about how it's actually worked out in production for DigitalOcean internally. But there's a lot of quirky things that you need to take care of when you're thinking about Docker files, and I'm sure you've realized that when you were doing Docker in development. And then it spits out another file as well, and that's called service.yml. That's specific to Cloud 66, so you can use that file to then take your project, your Docker file, and the service.yml and host it on a DigitalOcean server. But I'm pleased to say that since last week, we've released a newer version of Starter that spits out a Docker Compose as well. So if you don't want to use Cloud 66, fine by us. We would love for you to try it, but people have different preferences. You can use Docker Compose, run it in development. If you ever get into production, hopefully, we'd love to have you on Cloud 66. So let me show you a little bit about what are the things that we do at Starter. So we're all familiar with Docker files and how they work. Just a brief, kind of quick thing. I'm going to use a high-tech system I just discovered. I kept pressing this just to make sure that I can pair it with Bluetooth. I couldn't do that, but I realized that it's got laser. So, so Docker files, they have layers. You start from the base, and then you keep building these layers on top of each other. This is like a Java application. So you have a base of Linux. It's a Debian one. So those two essentially are the one instruction on your Docker file. Then you install your application server, your runtime, your application, well, the web server, and then application server. Then your application comes here. And here's the runtime, the file system. And the reason that's in red is because when you do Docker, obviously, you have your container running, the result of the image going into a container. Any change in the file invalidates the last layer, right? Which adds a kind of a challenge if you think about it that way. Now, who's familiar with like Rails as a framework? OK, that's great. Cool. Sometimes I go to like a node crowd, and I find myself completely out of skill. All right, great. Okay, so, for those who understand Rails, and it's fairly simple. You have like in Node, you have packages. In Rails, you have gems. In Python, all languages have these libraries, gems, shareable things. And there is a step always in this installation that you have to build those and download them from the GitHub usually, put them next to your application so your application is compilable essentially on its own, right? And every time we do something like bundle install in gem or npm install, we're changing a lot of files, which means that layer on top is changing a lot. So every time I have a Docker file, I add my source code to it, I run docker build, I'm downloading an npm install, for example, and then all of my files are invalidated, although I have not changed anything in your application. Now, what's the likelihood of me changing my code versus the likelihood of me changing a dependency of the application? I'm more likely to change a code than add a new gem or an npm, right? So you don't want to rebuild and invalidate all the cache layers based on that. So let me show you how a basic Rails, in this case, Dockerfile can look like. I start with the base, like a Ruby latest, which is a sanctioned Docker Hub official language. And I do a bunch of things here, which is usual, update, install, and then build essentials, Node.js for asset pipeline compilation, uglifying of the JavaScript files and squashing, compiling Sass and everything around that. I create the environment variable, then create that folder, set my work directory there, add my gem file, which is like my package dependencies in Rails. Think npm package JSON. Install those, which pulls them down, pulls those gems or npm or whatever package you have from GitHub, installs it, and I add my application from local build context to the folder, right? Now, it's kind of funny because this will essentially add that as well, because this gem file lives inside of that folder. But as you can see, as we kind of talked about it before in the previous slide, I want to add that one first, because the likelihood of me changing this is way less than this changing. So I add this one first, and then every time I change this one, of all these layers, each one of them obviously turn into a layer in Docker image, only this one gets invalidated. So my build becomes much faster. And that's basically one of the things, one of the most basic kind of best practices that you can do with Docker. Any questions so far? Cool. It's basically the same. Right. So if I were to feed one Rails application into stars, and I'll get into demo, the exciting part, excuse the slides, what are the things that we need to look into? First, we need to look into what gems, for example, you use, right? Now, if I wanted to just write Rails Dockerfile, obviously would be very simple. Add the gem file, add the source code, and then run a bundle install, get it built. But you might be using memcached, you might be using Redis, MySQL, Postgres, all sorts of things around that. ImageMagick. What are the dependencies for those things? What Linux packages do I need to install, for example, to have ImageMagick running in my Docker? Pretty much everything. Well, that's what we do, like stuff. Exactly. Luckily, it's not the same case for everything. So if you think about Postgres, you have just Postgres client, drivers, and things like that. And that's what Starter does. So it reads your gem file in case of a Rails application. Well, obviously, the first step is to detect what framework you're using. So it uses for clues. Oh, it seems like a Rails one. Starts with that, reads the gem file, and says, I can see ImageMagick. I'm just going to add a boatload of packages to the add part of the in apt install. I can see that you're MySQL, so I'm going to do MySQL client. Then it looks at your database YAML, so it creates the environment variables that you might want to need, and are fairly standard, MySQL password, MySQL username, MySQL host, URL, whatever else. And then also, every framework has its own kind of commands that you have to run. Again, going back to the example of Rails in this case, you have database migrations that change the schema of database. You want to run those if you have any database migrations. So those are the commands that you run at every build that you want to do that, right? Let's get to demo. OK, So how to install Starter? It's fairly standard with Brew. If you're running a Mac, pretty much everybody does. You should be able to try it now if you have internet. You basically just tap the Class66 tab, do a Brew install Class666 Starter, and you're up and running. It's a Go application. You can go to that URL. You see it on GitHub. Compile it yourself if you are into Go. It uses Go 1.5 experimental, which uses vendoring as well, so you shouldn't need any dependencies coming from the internet. It has everything you need to build it. I'm going to share the slides as well in case, so don't worry if it doesn't. OK, cool. Now, here's my application. Right. It's a fairly standard Rails app. It doesn't do anything fancy. I'm just going to run it now. What I'm doing here is I'm saying Rails server binded to all my network cards and start. Anybody see this? Do I need to make it bigger? All good? Sweet.
A little bigger, please.
A little bigger. Is it good? Or more bigger? There you go. Should be OK. Right. OK. Let's see what it does. It's a super complex thing. There you go. Fairly simple. It's got a SQLite database. Every time I refresh, adds an increases the counter, writes it to the database, and just as a random style on CSS, right? If I stop this and run it again, we were on 21. It goes 22, 23. So it is writing to database. Okay, and this is a kind of point that I want to demonstrate somewhere. OK, let's put this thing into Docker with Starter and run it in production. Here's what I'm going to do. I'm going to go to Starter. I'm running my Starter that I just built, so I'm using .starter. I'm pointing it to that project. OK, so it detected that I'm using a rack-based framework, Rails. It couldn't find the version of the Ruby, because I did not explicitly say what version of Ruby I'm using. So it's just going to say, I'm assuming latest. I'm going to assume latest. If I had something that said like Ruby 2.20, then it would add that, try to find that image on Docker Hub and use that as a from statement of your Dockerfile. I'm going to say yes. Now, it couldn't find any databases because SQLite kind of comes with everything that it needs. It doesn't need anything extra. Had I been using like MySQL 2 gem, then it would say, it seems you're using MySQL already. So I can demo it to you. I'm not it's not vaporware. I'm going to say there is no database. And these are a bunch of Ruby or Rails specific commands that it just suggests that you might run. What this one does, I mean, this is all gunk. This is the important part. Basically says, load the schema to database. Your database has the schema. I'm just going to say, yep, that's good. It's going to run it after each build. And then after each deployment, it's going to do the migrate my database. So in case I have a database migration, it will run it. They are not applicable to this case, but it's nice to have it. OK, there we go. So what it did is it created a Dockerfile and a service YAML. Let's go and see what Dockerfile it created. As you can see, it didn't create any. Oops. OK.
You have to run the starter twice.
Yes, exactly. You got me. So the reason it works this way, not the twice part, the reason it writes the Docker file into your source code and not nowhere else is basically, it's based on an assumption that I have my code, and usually my code and my Docker file kind of live side by side. If I add image magic, then I'll have to go to my Dockerfile and add a bunch of packages. So every version of my code is supposed to work with the same version of a Dockerfile. So they kind of are lockstep. And that's what it does. Fairly basic stuff, adds it there. But I can customize it. So it drops it in my source control. I can do a git add and add this to my source control, and that's my starting point, hence the name starter. But you have other abilities of saying, OK, this is a good start. Now I'm going to go and modify it, customize it, add my own packages, things you starter couldn't detect and identify. And that's fairly simple. We've seen all of this. Obviously, now you can identify that combination of these two commands together allows me to do all this in one layer instead of creating another extra layer on top and all things like this. And I'll get to that with when I'm talking about Habitus, which kind of takes care of these more advanced build structures. So that's that. Let's see if I can build this. So I'm going to go to this file, say docker build. Right. That's all I did. So now I have a Docker file, a Docker image. Let's run it. My Rails application is on port 3000. Let's see what's in it. I need a name. OK. Here's my application. OK, I'm running it inside. Now, one thing I need to do is to find my container's IP address, which is my Docker host IP address. And there you go. So now it's running inside of Docker container. Fairly simple. Now, you remember last time I stopped the one that was running natively, and I started again. It started from 21 to 22, so it was actually in the database. Now I'm going to refresh. So we were 25, 30, 34. I'm going to stop, kill the container, start again. I'm back on 25, because the database was the one that was persisted on the image. So that's a starter. Fairly simple. It just gets you a head start into having your application, usually web application, into this. And it does just slightly more than this. As well as detecting the framework, it would try to guess the port on the web server you're using. It also is compatible with proc files if you've used like Heroku, where you know that you have background processes that you want to run on proc files, like queue managers or email background senders and things like that that are not web service centric, and you usually put them in a proc file. So it would go and detect those processes and creates a new line for each one of them. So you basically can end up with a service composition of a bunch of containers, each one of them running your background processes, and then one for your web. And you can scale the web one, obviously. Don't scale the backend ones. Here's an example of a service YAML now it creates. So I mentioned that one of the other files that it creates, starter creates, is a service YAML. Service YAML is a service composition file that we use at Cloud 66. Think of it as Docker Compose for Cloud 66. It's more production-centric than Docker Compose, which is more developer-centric. So it's fairly simple format. I'm sure you're familiar with it. I have one service here, which was my web. Where do I get the Git repository source code for it? What branch that was? What command I need to run the server? What's the build and deploy command? The schema load and the migration, which we saw. Where is my build root? It's with the context of that build. Again, fairly simple. The port is on 3000. Now you notice that there's port 80 here instead of 3000, which basically means when I put it on production, I prefer to have it on port 80 as opposed to port 3000. I don't want to tell my customers to go on my domain colon 3000. And a bunch of standard environment variables. Am I going too fast or too slow, or is it good? Who thinks I'm going too fast?
Me.
Okay.
But it's okay. Keep going.
Ask questions. Okay. I don't want to leave anybody behind. Just ask questions.
Yeah.
Interrupt me.
Keep going. I'll jump in.
All right. Cool. Now I'm going to show you a little bit more complicated service YAML, just a little bit about how proc files are, and then we're going to put this into DigitalOcean server. So Cloud 66, the main application, the web application of Cloud 66 itself is written in Rails. Woo! That's why I'm so Rails-centric. And I'm just going to run starter against Cloud 66 itself and see what it comes up with. So I'm going to point it to a project that we internally call Maestro. Right. So again, we're not explicitly saying what version of Ruby we want. So it finds that. And it found MySQL this time. I'm saying yes, it found Redis, Elasticsearch, and these are the 3 databases that we use at Cloud 66 in the backend. Any other databases? No. It also found a proc file. And as you can see, we're using custom web, which is Unicorn for us. It's not Passenger, which is another application server for Ruby. We use Unicorn, which is what we prefer. Fay, which is our WebSocket real-time communication mechanism that updates everything and sends logs back to the UI. Scheduler, which is, you know what it is. And then you have different priority background workers. And it just found that. And again, it's going through load the schema, migrate, and spits out the files. Let's have a look at the files. So Dockerfile is, again, the same in this case. But here is the service YAML. Again, my web is running there. It detected that I'm using Unicorn. So it's using Unicorn instead of Rails S, or WebRick, which is the name for that. Now, I've got Fay, which was my WebSocket communicator. As you can see, it found out that I'm running Fay on Thin, which is another application server that handles WebSocket for us. Adds it there, detected the port 8080, and it's just going down to every single one of those processes. Now, at the end, just going to bring it a bit higher so you can see, there's a section called databases. And this is kind of the part that we're different from Docker Compose. Because we at Cloud 66, when you run your application on Cloud 66, we run your databases on a VM. We don't run it inside of a container. Because of that, if you tell us that you have MySQL, what we're going to do is we're going to connect your DigitalOcean account. We're going to fire up a single server, provision MySQL on it, the version that you want, and you can specify which version you want and all that sort of stuff. We fire up a MySQL. We fire up another server to put Redis on it. We fire up another server to Elasticsearch. Obviously, you can say, I want to share like Elasticsearch with Redis because my search load is not that much. But then what it allows us to do is you can just go to Cloud 66 dashboard or the command line and say, I want replication. What happens then is Cloud 66 will connect to your DigitalOcean account, fire up another server, baseline that, create a replication for you. As simple as that. And you can say, I want to have another Redis. And you can actually have things like, I want to have my main replica of my main database in Amazon and my backup on DigitalOcean. You can have cross-cloud, cross-data center replication even. So that's kind of a more complicated setup. Now, you saw the application. Let's go to Cloud 66. That's how Cloud 66 looks like. This is my dashboard, and we do a lot of dog fooding or drinking our own champagne or whatever that is called. And we deploy Cloud 66 pretty much with Cloud 66. So what I'm going to do is I'm going to get the Dockerfile that we created and the service YAML and see if I can host that application up on DigitalOcean. OK, so here what I'm going to do is I'm going to give my stack a name. I'm going to say what environment I have, and you can create environments as much as you want, as many as you want. This is my web. Where did it come from? That's my source code. And I can use the service YAML here, but in this case, I'm just going to show you the old school way. That's my Git. My service is available on port 3000. I did not use any databases, obviously, while it's SQLite. I'm going to say next. OK, so now I have an option of choosing a cloud provider that we support or deploying on a server that I already have. I'm going to say a cloud provider. Obviously, I'm going to choose DigitalOcean. I'm going to go to New York 2, say, and what size of server I want, say 1 gig. Off we go. It's going to start building it. So DigitalOcean is going to give us a server under your account. This was actually my account, but it will be yours. Give us a server. We then connect to it, blast it with basic everything, package it. We don't install anything that's ours apart from one open source agent that monitors your IP address changes in case you bounce your box or there's a crash or DigitalOcean decides that they want to move it to another physical, so the IP address might change, and also monitor the heartbeat to make sure that you know if your server becomes unavailable. And this unavailability could be because the network's got an issue or it's under huge load, so you can't even run a cron because your CPU is saturated. That's it. Everything else is exactly your server. You can SSH to that server. You look around. It looks like exactly you run your Ansible or Chef or Puppet or whatever rocks your boat scripts on it yourself. You'll find everything the same way. Everything is open source. There's Nginx there for your web. If you have a load balancer, on DigitalOcean, we can actually do load balancers, which is HA proxy. We can do that. And if you're using, say, Amazon, then we do ELB. You can just do whatever you want. OK. This is going to take a while because it's going to just build and install all that sort of stuff. So here's the one I prepared earlier when I was in that room. So this one's building. This is the one I created with the same setup. And here it is. So as you can see, I did that before a couple of refreshes, so I'm on 4 here. And you can actually go to that URL, firefly.docker-101.c66.me, and you'll see the app. And that was as simple as that. We didn't do anything fancy. I can do exactly the same thing and have databases and everything else around that. OK, great. Any questions so far? Sweet. OK, so that was Starter, which is about getting started with Docker. It supports Rails, Node, basic Python, Django, not much of it. We hope that you like it. We hope that you contribute to it if you want. Again, it's something that will help everyone. And it doesn't not necessarily just create classic 6 files. It would do Docker Compose as well. If you are a Java developer and you want to contribute to that, you're more than welcome to do that.